Consider the following Ruby program. It adds two numbers passed to it on the command line and prints the sum. This is a simple program that consists of primarily of variable assignment and method invocation. What makes it particularly simple? It is a purely sequential execution. 4 lines of code are executed one after the other without branching or repetition. It is a rare program that can be this simple. This section introduces Ruby's control structure, which alters the sequential execution or flow of control of a program. We cover conditionals loop in this presentation. Conditionals. If the most straightforward of the conditional is if. In its simple form, it looks like this. Unless. Unless as a statement or a modifier is the opposite of if. It executes code only if an associated expression evaluates to false or nil. Its syntax is just like if, except the else if clauses are not allowed. The case. The case statement is multi-way conditional. There are two forms of this statement. The simple and not frequently used form is nothing more than an alternative syntax for if or else if or else. As you can see from this code, the case statement returns a value, just as the if statement does as with the if statement. The then keyword following when the values clauses can be replaced with the new line semicolon. Then we look at loops. This section of the video describes how Ruby's simplest looping statement, while, until, and for. Ruby also includes the ability to define custom looping constructs known as iterators. Iterators are probably more commonly used Ruby's built-in looping statements. The for or for-in loop. The for loop or for-in loop, it iterates through the elements of an enumerable objects, such as an array. On each iteration, it assigns an element to a specified loop variable and then executes the body of the loop. A for loop looks like this. While and until loop. Ruby's basic looping statements are while and until. They execute a chunk of code while a certain condition is true or until the condition becomes true. For example, methods, procs and lambdas and clauses we're gonna discuss next. Methods. A method is a named block of parameterized code associated with one or more objects. A method invocation specifies the method name, the object on each it is to be invoked, and 0 or more argument values are assigned to the name method parameters. The values of the last expression evaluated in the method becomes the value of the method invocation expression. Blocks. Like methods are not objects that Ruby can manipulate. A proc object represents a block, like a method object. We can execute the code of blocks through the proc and represent it. There are two varieties of proc objects called procs and lambdas, which have slightly different behavior. Both procs and lambdas are functions rather than methods invoked on an object. An important feature of procs and lambdas is they are very closures. They return access to the local variables that were in scope when they were defined, even when the proc or lambda is invoked from the different scope. After covering methods, we turn our attention to procs and lambdas, explaining how to create and invoke them, and also detailing the somewhat subtle differences between them. This is followed by a section of method object which actually behaves much like a lambda. Now we're going to pay our attention on defining simple methods. Methods are defined with the def keyword. This is followed by the method name, an optional list of parameter names in parentheses. The Ruby code that constitutes the method body follows the parameter list, and the end of the method is marked with the end keyword. Parameter names can be used as variables within the method body, and the values of these named parameters come from the arguments to method invocation. Here is an example method. Method return value. Methods may terminate normally or abnormally. Abnormal termination occurs when the method raises an exception. The factorial method shown earlier terminates abnormally if we pass it an argument less than 1. If a method terminates normally, then the value of the method invocation expression is the value of the last expression evaluated within the method body. In the factorial method, that last expression will be either 1 or n into factorial n minus 1. The return keyword is used to force a return prior to the end of the method. If an expression follows the return keyword, then the value of the expression is returned. If no expression follows, then the return value is nil. In the following variant of the factorial method, the return keyword is required. Now we're going to look at blocks. Blocks are syntactic structures in Ruby. They are not objects and cannot be implemented as objects. It is possible, however, to create an object that represents a block. Depending on how the object is created, it is called a proc or lambda. Procs have block-like behavior and lambdas have method-like behavior. Both, however, are instances of class proc. Creating a procs. This method creates a proc from a block. With a make proc method like this defined, we can create a proc object from ourselves. Let's see how lambdas differ from procs. A proc is the object form of a block, and it behaves like a block. A lambda has a slightly modified behavior and behaves more like a method than a block. Calling a proc is like yielding to a block, whereas calling a lambda is like invoking a method. Now we are going to look at classes and modules. In many object-oriented languages, this is done with constructor. In Ruby, it is done with an initialize method. Creating the class. Classes are created in Ruby with the class keyword. Like most Ruby constructs, class definition is delimited with an end. Initializing a point. When we create new points objects, we want to initialize them with two numbers that represent their x and y coordinates. In many object-oriented languages, this is done with a constructor. In Ruby, it is done with initialize method. This is only 3 new lines of code, but there are a couple of important things to point when def is used like this with an unqualified method name inside of a class definition. It defines an instance method for the class. An instance method is a method that is invoked on an instances of a class. Now we're going to look at arrays and hash access with square brackets. Ruby uses square brackets for array and hash accesses. It allows any class to define a method and use these brackets itself. Let's define a method for our class to allow points object to be treated as read-only arrays of 2 or as read-only hashes with keys x and y. Class variables. Class variables are visible and shared by the class methods and the instances of methods of a class, and also by the class definition itself. Like instance variable, class variables are encapsulated. They can be used by the implementation of a class. They are not visible to the users of a class. Class variables have names begin with double @ marks. There are no real need to use class variables in our point class. But for the purposes of this tutorial, let's suppose that we want to create data about the number of point objects that are created and their average coordinates. Now we discuss class instance variables. Classes are objects and can have instance variables just as other objects can. The instance variables of a class, often called class instance variable, are not the same as class variables, but they are very similar enough that they can often be used instead of class variables. An instance variable used inside a class definition but outside an instance method definition is a class instance variable. Like class variables, class instance variables are associated with the class rather than with any particular instance of the class. Now, talking the disadvantage and advantages of class instance variable, we can say a disadvantage of a class instance variable is that they cannot be used within instance method as a class variable can. Another disadvantage is the potential for confusing them with the ordinary instance variable. One of the most important advantages of class instance variable over class variable has to do with confusing behavior of class variable when subclassing an existing class. Before ending this presentation, I would like to mention a few things we discussed earlier. This video begins with a quick start to the language and then explains the language in detail from the bottom up. From the lexical and syntactic structure to data types to expression and statements on through methods, blocks, lambdas and closures, classes and modules. The video demonstrating the heavily commented example code, and it is written for experienced programmers who are new to Ruby and for the current Ruby programmers who want to challenge their understanding and increasing their mastery of the language as well. Thank you for watching our video presentation.